So you have your metabolism, right?
Right.
So your metabolism is how things go through your body, breakdown, right? In your diet, things like that. So you have catabolism and anabolism, right?
Right.
So one of these is going to be putting things together, and one's going to be breaking them apart.
Catabolism puts them together, and anabolism takes them apart.
Opposite.
Okay, I thought so. And I was like, oh.
So catabolism, we're going to take something bigger, and we're going to make it smaller.
And does that take ATP to break things down like that, or does it provide ATP?
It kind of depends what reaction you're talking about. This is very broad.
Okay.
So, for example, you could say catabolism would be maybe glycolysis. We can say this is a glucose molecule.
Uh-huh.
And we're going to make 2 pyruvates.
Then that would take.
So that would be like an example.
Okay.
Basically, the root definition is going to be something bigger, and we're going to break it down to smaller pieces.
Okay.
Whereas anabolism, what do you think that'll be?
It would be putting together.
Right.
Through ATP.
Depending. Most likely.
Like that guy.
When would you use anabolism? Because I know catabolism breaks down food and it breaks down molecules and it does that, but when would you use anabolism to put things together?
Maybe if you were going to synthesize some proteins. So maybe amino acids, and you'll make some proteins.
Okay. So like with the protein channels kind of a thing, with the ligated?
Different.
Different?
Different. This would be as if, like, let's say, because both of these are going to go under our metabolism category. So catabolism would be maybe breaking down glucose. Here would be maybe, okay, we need proteins in our body, like the electron transport chain. Yeah. We're going to need to make those proteins using amino acids so we can go through the cycle.
Oh, okay.
You can think of it as cats have claws. I'm not a huge cat fan, so cats like ruin things. They're gonna like tear apart your sofa, big things, small things. Whereas anabolism or ants, they work as like little colonies, and they would like build up their ant hills. So anabolism, build up. Catabolism, break things down.
That's cool. I like that.
Okay, so let me draw that picture up.
A beautiful detailed picture.
Beautiful picture.
Spent so much time on this.
I could tell you spent all night.
Oh, I did. Planning it.
Planning it.
Okay, so you got that down.
Metabolism is. Oh, these are mother cells. Okay.
Yep. Okay, and then in our metabolism, we have 2 types of pathways that we're going to do. We're going to have aerobic and anaerobic.
Explain.
Explain it, he says.
Go for it.
Here we go. So we have aerobic. And what was our other one?
Anaerobic.
One uses oxygen and one doesn't use oxygen.
Okay, which one do you think would be the...
Anaerobic doesn't use oxygen, and aerobic uses oxygen.
Perfect.
So that's accurate.
This one we don't have oxygen. This one we do.
Okay, I didn't know that.
Both of these processes, no matter which one you're doing, we're going to start with glycolysis.
Can you start with glycogen as well? Let me show you.
You show me. Because with glycolysis, we're going to start with our 6-carbon molecule called glucose.
Here it is.
VIP pass?
So
For what?
You gotta do this, you gotta do this.
What is it?
It's red?
The Rexburg run.
Oh, I want to do that. That looks like so much fun. Did you do it last year at all?
No,
Mm.
that was on a mission.
Ah,
Nice.
Serve with the Lord.
Oh, that's true.
I
I had a roommate that went to this last year. She said it was a blast, but it's $40, dude.
Races are so
Well, it's
expensive.
better than the 8.5 for the Teton.
Oh, that's
I'm
true.
doing the Teton
Yeah. Are you doing it this weekend?
too. I think so.
Is that this weekend?
Yeah.
Oh yeah, it's right here.
So they both start with glycolysis?
Yep.
Okay.
Yeah, right here. So we can take a look at, can you take a look at this? So this is my exercise phys lab. You can start from glycogen, or you can start from glucose.
Oh, okay.
This is once in its regular form, and one is the transfer.
Glycogen
I
already.
like that way of doing it.
That's a cool chart.
That is a way cool chart.
Yeah.
That simplifies it very nicely.
That was good.
I like that.
Classes,
It really is. It's nice.
I know.
Because they all talk about the same thing, just at different times. or in different ways.
Yeah, mine.
Yeah, so glycogen and glucose can go through glycolysis. Just form of sugar.
Because glycogen is just another form of
sugar.
Yeah, sugar.
Mhm.
So makes sense.
Yeah, because you can make glycogen and then turn that into glucose, and then you send it through glycolysis.
Mhm.
So what's glucose look like?
C6, 12, H12, 06.
Beautiful. This is sugar.
Sugar.
It's a 6-carbon molecule, right? What is that supposed to be? 6 carbon?
Mm-hmm.
Okay, so if we do have oxygen, this is kind of the normal pathway we'll always will follow because
We'll go
we
into
breathe oxygen.
pyruvic acid.
Mm-hmm. So through glycolysis, we're going to go from glucose and make 2 pyruvates.
Now, question: when you're breaking down, question. When you're breaking out the carbons, you're also breaking down the hydrogen and the oxygens as well.
Correct.
aren't you? So when it goes down to the 3 and 3, it goes for hydrogen 6 and 6 kind of a thing.
Yeah. Mm-hmm.
But we just do the C's to make it simple.
Make it really simple. Yep, because here, I mean, we could, if we wanted to, draw all the different bonds.
Mm-hmm.
But to simplify it for this class's purposes, you just make it.
Okay. Because I was watching a video about that, and he was breaking them down, and I was like, oh.
Where did those come from? But
I
yeah.
did not know that.
That's why when we'll go through the whole process of glycolysis in a minute, and I'll kind of show you why do we get from NAD to NADH.
Because you're taking out the
hydrogens, because that's when we're going to put on some pyruvates.
Mm-hmm.
So we're kind of saying we'll give you, or putting on pyruvates, putting on phosphate, because we're taking off the 2 hydrogens that were bound there.
Yeah, I'm putting them with NAD, and so it's NADH2 because you're taking
Right.
2.
Exactly.